So very good morning, you people. Today we're talking about once again one of the great concept the people are struggling to understand. First thing is that glass lab, in the glass lab, we have to prove that angle of incident is equal to angle of incident is equal to angle of emergence. So angle of emergent. So I have to prove that angle of incident is equal to angle of emergent. Second one is that I want to find out the lateral shift. So lateral shift value I have to find out. So I have to find out my angle of incident is equal to angle of emergent. First I have to prove. Second thing is that I want to prove lateral shift. So I want to prove a lateral shift. What is the value of lateral shift? How to find out the value of lateral shift? Let's see one by one, guys. So before that, so we want a Snell's law. Generally, everybody knows about Snell's law and refractions or reflection. So let us say this is a transparent medium. Let us say medium one, this one, medium one, this is medium two, this is medium two, this is medium one, and this is medium two. The separation between this medium one and medium two is that is interface. Now let's say, guys, here the refractive index of medium 1 is n1, the refractive index of medium 2 is n2. Now I have to incident a light ray. It make an angle of incident, that is small I, and it have light never goes the deviations until another medium is encountered. So now the medium is encountered, so it will deviate. So this angle is that R. Now I want to write down the Snell's law for this one. So how to write down the Snell's law? So Snell's law, how we have to supposed to write, guys? So very simple. The incident medium. What is the incident medium? Refractive index n1. This is the incident medium refractive index n1. And what is the angle of here? I. Sine of angle of I. Sine of angle of incident, that is I, is equal to another medium refractive index. What is the other medium refractive index? N2. N2 is the another medium refractive index, and we have an angle here. That angle is called as angle of refraction. So sine of angle of refraction. So this is called as Snell's law. So this is called as Snell's law for this XY interface. So this XY interface of Snell's law is that n1 sin I is equal to n2 sin R. So what is n1 here? Refractive index of the medium 1. n2 here, refractive index of medium 2. And I is that angle of incident. This is angle of incident. And R is that angle of refraction. So by using these four variables, generally we have to write down the Snell's law. Let's see, guys, here now our motto is we want to prove angle of incident is equal to angle of emergent in a glass slab. So let's see, guys, here now I am taking a glass slab of thickness of T I am taking the glass slab thickness of T, and once again this is the air, I hope. This is the glass and this is air. So now I am taking a refractive indices n1, this is n2, this is n1. Why? Because this is air and this is also air. Both are air only. This air and this is also air. The refractive index is n1 is air. The glass slab refractive index is n2 and n1 is the air of refractive index. And this T is the thickness of the glass slab. So thickness of the, let us say, ABCD. In this ABCD, A is called thickness of the glass slab. So thickness, that is T. Thickness of the glass slab. Now what I have to do is that I have to take a normal line. Otherwise, first you go with the point of incident better. So now I have to make an incident. I take a laser light. I have to incident the light ray, and at the point of incident I draw a normal line. Let us say, guys, here this is I1 and angle of incident I make it as I1. and now the light ray travel from air to glass. So it is denser medium. So what will happen, guys, here? It is towards the normal line. Towards the normal line, we have to move the refractor ray. So now here is that I have extended this incident ray. Now here is the point of incident for the CD surface. For CD surface is the point of incident. So this is the point of incident, CD surface. So what is this angle, guys? R1. And what about this angle? So we know this is alternate angles. Alternate angles are equal according to mathematics. So R1, this is also become R1 only. Why? Because this is R1 and R1 both are alternate angles. So these two are parallel lines. These two are parallel. This is transversal line. So R1 is equal to R2 according to that. Now we have to go to emergent ray. So this is the emergent ray. So this is the emergent ray. So the angle made here is that I2. So I want to prove that I1 is equal to I2. So according to alternative angles, R1 is equal to R2. Let us say N dash, M dash, A O B D, A O B D. So see, guys, so N dash parallel to M dash, N dash parallel to M dash. Because of that, R1 is equal to R2. Now apply Snell's law for the interface AB. Now I am applying Snell's law for this one, guys. Apply Snell's law for AB surface. AB refracting surface. So apply, guys, what you get? So AB, what is the refractive index of incident medium? N1 sin of I1 is equal to, what is the refractive index of second medium? N2 sin of R1. Keep in mind, guys, sin of R1. So I have to implement Snell's law for AB surface. Let us say equation 1. Now I am implementing Snell's law for CD surface. So let's see, guys, here now this become a medium 1, this become medium 2. So according to that, so N2, so now I am apply Snell's law for CD surface. I am applying Snell's law for CD surface. Applying Snell's law for CD surface. So let's see, guys, here this is medium 1 nothing but N2 sin R2. Let us say this is made as R2 now before we enter. So sin R2 is equal to, this is N1 sin I2. But we know what, guys, from this transversal line N dash parallel to M dash. So this is transversal line. BD is a transversal line. That become alternate angles. Interior alternate angles. Now what will happen, guys? R1 is equal to R2. Now in the place of R2, what can I write? N2 sin R2 is equal to N1 sin R1. So why? Because R1 is equal to R2. Because of that, N2 sin R1 is equal to N1 sin I2. So let us say equation 2. So observe, guys, here. So it is in the form of N1 sin I1. A is equal to B. So B is equal to C. So A is equal to B. B is equal to C. Then what you have to get? A is equal to C. So I am applying this one. A is equal to C. What is A here? Guys? What is A here? What is A? N1 sin I1 is equal to, next what is C here? N1 sin I2. N1 sin I2. So N1 cancel, sin ratio cancel. So what you get? I1 is equal to I2. What is the meaning of it? Angle of incident is equal to angle of angle of emergent. So I hope you people are understood in the class lab. So let's see now. I want to find out lateral shift. How much shift is happened? I want to find out lateral shift value. I want to calculate the lateral shift value. For that, I have to do same experiment. So let's see guys here. Once again, I am taking a glass slab. I am taking a glass slab of thickness is T. Once again, I have to insert light ray. So this is goes to here. So I have to extend it. The incident ray, and now I take a normal line here. Why? Because this is the point of incident. Now it goes like this. So this is the angle here. This is also I1. This is also I2. This is R1. This is also what guys? R1. R1. So thickness of the glass slab how much guys? Just now we have to say thickness of the glass slab T. Let us say A, B, C, D, E, F, G, H. Now we take a perpendicular. I want this distance. From G to, I want this distance. Let us say I. So GH I want. So GH is called what? Lateral shift. So this is exactly lateral shift. GH is called lateral shift. GH is called as what guys? Lateral shift. The GH value is called a lateral shift. I want to find out that value actually. That is the main motive for me. So for that, so I have to simply extend this line also. I am extended this line. I make it as J. Now I am taking a triangle. Let's say guys triangle F G I. I am taking this triangle. So before that, what is the angle this one? This is the angle of deviation guys. This is the angle of deviation. Already I told this is an angle of deviation for refraction. So what is the angle of this? I1 minus R1. I1 minus R1 is the angle. So this angle is how much guys? I1 minus R1 is the angle. So now I have to go with sine I1 minus R1 is equal to. So what is the sign meaning? Opposite. So when the right angle, here is the right angle. Keep in mind guys, this is the right angle. So opposite, what is the opposite here? So opposite GA by hypotenuse. Hypotenuse is FG. So GA means what? GA means what? Lateral shift. GA means what? Lateral shift. So GA is equal to lateral shift. FG is equal to, this is refractor ray. So I want to find out GA now. So for that I am taking another triangle. Let's say guys here I am taking triangle FJG. Let's say guys here FJG. This triangle I have to take. I have to consider. So what is this FJ value? Thickness of the glass slab. So here FJ is equal to nothing but AD, which is equal to what guys? Thickness of the glass slab. So now I have to go with which angle? Shall I go at which angle? So cos R1. So cos R1. So what is the formula for cos R1? So this is the right angle, no issue. This is the right angle. Okay. Cos R1 adjacent. What is the adjacent? Cos R1 is equal to adjacent Fj by what is the hypotenuse, guys? Hypotenuse is nothing but Fg. Hypotenuse is nothing but Fg. Hypotenuse is nothing but Fg. So what is the Fj value? Cos R1 is equal to Fj value is T by Fg. Now what I have to do that? I want Gi value. Gi, for that let us say equation 1. This is equation 2. So this is equation 1. This is equation 2. Shall I go with 1 by 2? 1 by 2. So now what do you get, guys? 1 by 2. What is the 1 value? Gi by Fg. Gi by Fg by T by Fg. T by Fg is equal to sin I1 minus R1. Sin I1 minus R1 by cos R1. Cos R1. Now this Fg cancel. So now what you have to get? Now what you have to get? Gi by T is equal to sin I1 minus R1 by cos R1. I1 Gi by T is equal to sin I1 minus R1 by cos R1. So Gi is equal to what you have to get? T into sin I1 minus R1 by cos R1. So what is Gi? Already I told this is lateral shift. So lateral shift, the Gi is called a lateral shift. The lateral shift Gi is equal to T into sin I minus R1 by cos R1, which means it depends upon the thickness of the glass slab, it depends upon the incident angle, it depends upon the refraction angle. Keep in mind, guys. Thank you.